Morning everyone, here's a quick video on subatomic particles. Alright, when I say subatomic particle, I'm talking anything that's smaller than the atom. Sub meaning smaller, atomic meaning atom. So these are what make up an atom, the building blocks, and what we focus on in this class are electrons, protons, and neutrons. Let's talk electrons first. Usually I'm lazy and I abbreviate electrons E with a little minus sign. The reason it has that little minus sign is because electrons have a -1 charge. They're located outside of the nucleus in the electron cloud. And just a little refresher, J.J. Thomson discovered the electrons with his cathode ray tube experiment. These are all the different clouds. Remember, we know that really electrons are likely to occupy a certain space. We have like probability densities of where we might find these electrons. So these are different energy levels, kind of like Bohr had different rings, but different shapes or areas that are likely to find an electron depending on what the atom might is. So there's kind of just different shapes as we get bigger and bigger. Some kids call these like flowers, but really they're meant to represent where the electron's located. Electrons have no significant mass. Actually, everything has mass, but the mass of an electron is 1/1800 atomic mass units. So really, if you put that into kilograms, it's to the -31st, 9.1 times 10 to the -31st kilograms. So 0.000, enough to move the decimal 31 times and then 91. So I would have to move the decimal 31 times over. That's a very, very small mass. So basically, we say it's not significant at all, no mass. Ernest Rutherford discovered the nucleus with his gold foil experiment. He shot alpha particles at a thin piece of gold foil, and some of them bounced back or got ricocheted. So he knew there had to be a positively charged center of the atom, and then the rest was mostly empty space. And we now know that the nucleus contains protons and neutrons. Protons, I will abbreviate P with a little positive. The reason it gets the positive is because they have a +1 charge. They are located in the nucleus, and here's the key idea on this slide. The atomic number is the same as the proton number. So if you change the number of protons, you change the element. Okay? Oxygen always has 8 protons because it has the atomic number 8. Iron always has 26 protons because it has the atomic number 26. The proton does have mass. It's 1 AMU, 1 atomic mass unit. Still very, very small. That's to the -27th kilograms, but big enough that it's significant. We need to count the mass. So 1 AMU. The mass number is the weight of the nucleus. So the nucleus remembers protons and neutrons, and there's a couple words that they sound very similar, so I just want to clarify. The mass number is always adding protons and neutrons. So this is always going to be a whole number, how many protons added to how many neutrons. On your periodic table, you have the atomic weight, the average mass, the average atomic mass, whatever it might say on the version I gave you. This is the average of all the masses of different isotopes, and isotopes are just varieties of that same atom. So just know right now we are not using this number. This guy right here, we're not using it. When I ask for mass number, I just want you to look at that atom, how many protons and plus how many neutrons. And the last subatomic particle is the neutron. I abbreviate it N with this little exponent of 0 because it has no charge. It is neutral. It is located in the nucleus. James Chadwick made the discovery, I believe it was actually in the 50s, 1952. That's my typo. Sorry about that. And the mass is 1 AMU, 1 atomic mass unit. So this periodic table you have is going to be really helpful. Here's kind of an example, but it has your elements, and the atomic number, remember, is the number of protons. And then the average mass we are going to ignore right now. Really, we're focusing on protons plus neutrons. So if I ask for mass number, you're going to take protons and add it to neutrons to get the mass number. Hopefully this was quick and painless and a little bit helpful.